afternoon students, class 9. In this video, in previous video we had studied about the physical and chemical properties of hydrogen. Now in this video we are going to start uses of hydrogen. Hydrogen is used in the form of fuel. Why? Due to its high heat of combustion. Due to its high heat of combustion, hydrogen is used in the form of fuel, in the form of coal gas, or in the form of water gas, as well as in the form of its liquefied form. Due to its high heat of combustion, this hydrogen is used in the form of fuel. To produce in the form of fuel as coal gas or water gas, or in the form of liquefied hydrogen. Now second is oxyhydrogen torch. When mixture of hydrogen and oxygen is boiled in a specially designed furnace, and then the flame which is obtained bears the temperature of 2500 degrees centigrade. When the mixture of hydrogen and oxygen is boiled in a specially designed apparatus known as oxyhydrogen torch, then the flame which is produced provides the temperature of near about 2500 degrees centigrade. And due to this high temperature, this flame, which is also known as the oxyhydrogen flame, is used in cutting and welding of metals, for melting platinum and quartz, for fusing alumina, to produce synthetic rubies and sapphires. Again listen, this point is important for the short note. When the mixture of hydrogen and oxygen is boiled in a specially designed apparatus known as oxyhydrogen torch, then the flame which is obtained provides the temperature of near about 2500 degrees centigrade. And due to this high temperature, this flame is used in cutting and welding of metals, in the melting of platinum and quartz, for fusing alumina, to produce synthetic rubies and sapphire. So this type of flame is also known as oxyhydrogen flame, and the apparatus is known as oxyhydrogen torch. Now next use of this hydrogen is atomic hydrogen torch. When hydrogen is boiled in a specially designed apparatus, then the flame which is produced is able to provide the temperature of about 2800 degrees Celsius. And due to this high temperature, this metal is used for welding alloys containing metals like tungsten, manganese, or chromium. Next use of hydrogen in atomic hydrogen torch. Again listen. When hydrogen is boiled in a specially designed apparatus known as oxyhydrogen torch, the flame which is obtained is able to provide a very high temperature, about 2800 degrees centigrade. And due to this high temperature, this flame is used for welding alloys containing metals like tungsten, manganese, and chromium, etc. Next use, fourth is hydrogen is also used in self-lighting gas jets and automatic lighters. There is nothing to explain in these points. Next use of hydrogen is the manufacture of ammonia by Haber's process. Hydrogen reacts with ammonia, reacts with nitrogen in presence of nickel, in presence of suitable catalyst to produce ammonia. And this process of production of ammonia by reaction of hydrogen with nitrogen is known as Haber's process. So this hydrogen is also used in the manufacture of ammonia by Haber's process. Next use for hydrogenation of vegetable oils. Just in the property in the previous video we had studied about the hydrogenation. Now hydrogen, all you know, organic compounds, some organic oils, for example coconut oil or groundnut oil, these are which are also known as vegetable oils. They are in liquid state and it is not easy to transport from one place to another. So through these oils, hydrogen gas is passed in presence of a suitable catalyst, and due to passing of hydrogen gas, these vegetable oils which are in liquid state, they are converted in the form of semi-solid ghee-like structure, and that is known as Vanaspat ghee. This conversion of liquid vegetable oils into semi-solid ghee-like structure by using hydrogen is known as hydrogenation of oils. This in this way we have seen this hydrogen is also used in this process of hydrogenation. Next is for producing artificial petrol or from coal. When hydrogen gas is passed under high pressure over powdered coal, then a product which is just like petroleum is obtained. When hydrogen gas is passed through powdered coal under high pressure, then in presence of a suitable catalyst, a product is obtained which is just like petroleum, and this is the reason why, or you can say petrol, this is the reason why we can say that hydrogen is also used in the manufacture of petrol. And next is for extraction of metals from their ores. The extraction of metals from their ores. Suppose this one is copper oxide. In the same way, one or two example you can see. This one is ferric oxide. When hydrogen is reacted with these oxides, then these metallic oxides are reduced into their metallic forms, and water is produced in the same way here using 2Fe and plus 3H2. Now, what is the special feature in these reactions? You see, hydrogen is responsible for removing oxygen from this metallic oxide, and when this hydrogen is combined with oxygen, then it will give rise to water, and this copper oxide is reduced into copper. So from the metallic oxides we are able to obtain metals in their pure form, and we can say that hydrogen is used in the extraction of metals from metallic oxides. Clear? Now, in this reaction, hydrogen is oxidized and the metallic oxides are reduced. Now, next thing. Next heading is oxidation, reduction and redox reaction. Oxidation, reduction and redox reactions. Now, oxidation. What is oxidation? Combination of oxygen. Oxidation can be defined in 4 different ways. Number 1, combination of oxygen is known as oxidation. Combination of oxygen is known as reduction. Oxidation. Second, removal of hydrogen is known as oxidation. Third, increase in plus charge is known as oxidation. Increase in plus charge is known as oxidation. And fourth, decrease in minus charge is also known as oxidation. In this way, oxidation can be defined in four different ways. In the same, all those reactions in which these activities take place, either oxygen is added, or hydrogen is removed, or plus charge is increased, or negative charge is decreased. All those reactions will be termed as the oxidation reactions. On the other hand, reduction can be defined again in four ways. First is, that is removal of oxygen is known as reduction. Second, combination of hydrogen is known as reduction. Third, decrease in plus charge is known as reduction. And fourth, increase in negative charge is known as reduction. So oxidation and reduction both can be defined in four different ways. Now, next term is redox reactions. All those reactions in which reduction and reduction, both the process take place side by side. All those reactions in which oxidation and reduction, both the process take place side by side, are known as redox reactions. For example, you can take CuSO4 plus zinc in the same way, copper oxide plus hydrogen. In this reaction, you see it will give rise to ZnSO4 and plus Cu. In this reaction, it will give rise to Cu plus H2O. Now here you see, in copper sulfate, that is compound, copper has plus 2 charge, but here there is no charge on copper. So decrease in plus charge is known as reduction. So we can say copper sulfate has reduced into copper. Here zinc has no charge, but after reaction with sulfate, it will develop plus 2 charge. So we can say zinc has been oxidized. It means in this reaction, the zinc is oxidized and copper sulfate is reduced into copper. In the same way, in second reaction, hydrogen is combined with oxygen. So we can say hydrogen is oxidized. And from copper oxide, oxygen is removed. So we can say copper oxide is reduced into copper. So in both these two reactions, the oxidation and reduction, both the processes take place side by side. So these are the reactions, these are the examples of redox reactions. Now how can we define? All those reactions in which oxidation and reduction, both the processes take place side by side, are known as redox reactions. Okay, in this way, this chapter hydrogen has been completed. This is the current chapter, and you can prepare easily for your test.